All right. Thank you, everybody, for joining us. This is the JETSON AI Lab Research Group, and I'm Dusty from NVIDIA. We're back again. It's been a very exciting couple of weeks since we kicked off this group and had a lot of great contributions from the community that we're going to dive right into. And in addition to planning out what we got next, we got a couple guest speakers today from CMU and OStream to talk about the work that they've been doing. So with that, let's just go over some like programmatics real quick. If you want to like chat or ask questions at any time and we're just like talking away, please feel free to raise your hand or type it into the group chat. I'm gonna keep an eye on that today and try to address any questions that you have. With that, let's just dive into the progress that we've made over the past couple weeks here. And go over the agenda for today's meeting. Can everybody see my screen? Yeah, good. Okay, so on the docket for today, we added Ollama support. We added Piper TTS that's been optimized and have gotten HomeAssistant to run on the JETSON. There's some stuff about new Jetpack 6 updates, new updates to the core inferencing libraries, TensorRT LLM work ongoing, things like that. And we got a big thing, we have to update the JetBot and EDU robotics kits for over Nano now that we have got all this AI stuff running on that. Okay, so with that, the first major topic let's dive into is the Ollama support, which has been in progress for like a while now. And since that was written in Go, I was kind of like unable to hack that in myself. But we had this great contributor, Remy415. I actually don't know who this is. If you're on the call though, it would be great to like learn more about this guy. But I think he is a contributor in Ollama project and has ever so kindly figured out how to get it working on JETSON and contributed the Docker files and containers for that. And I posted this earlier, I think it was like late last week to show it all running. And it is like super easy to use. And then just yesterday, somebody else showed how you can hook this up to the Open Web UI, another container that you can run on JETSON. And this one doesn't need recompiled because it just is CPU only. It doesn't do the actual GPU stuff. And I have this running here, and you can just go back and forth and chat with it. I mean, there it goes. And Ollama is nice because it has lots of models in there. It's kind of like a easier version of Hugging Face, I would say. It does just use llama.c++, so it gets like that level of performance. And see what other stuff we can do with this. But it is kind of like a more streamlined version of the text generation web UI, if you're familiar with that. And as we'll see, this gets used in other packages that we're going to be using in the future too, like Llama Index. And we're starting to do more RAG examples for the JETSON AI Lab about text-based RAG and things. So this container's out now. You can go and find it. Thank you everybody who's contributed to this, because this has been a long running thing in the community to get Ollama support. And you can still go onto Hugging Face and do any GGUF models through llama.c++ that you want. But there's also really a lot that Ollama already wraps up for you and seems to be the entry level API that has good enough performance and is super easy to use. And also HomeAssistant has very good Ollama integration too. So we're really killing multiple birds with one stone on here. Let me see if there's any questions here. There was a question about, for Nano LLM, what's the proposed developer setup? You can either, there's docs in there that I'll go over a little later. You can either build your container on top of it, build it in it, or use yours as a base image, or just mount your project files into the container. Okay, let's shift gears to what we've been working on with the HomeAssistant, which there's been a lot of progress with that, thanks to Mazeko, Ridge Run, and Nabukasa, who's contributed a lot of like the Piper stuff and other Wyoming protocol containers we're starting to get to. And also we have the actual core container running on JETSON now that will run the Home Assistant system itself on JETSON. And I have a basic version of that going here on my Edge. I haven't had time yet to actually set this all up with like a bunch of sensors. I just have some like RTSP cameras that I plugged into it yesterday just to make sure the video was working and everything. But eventually we'll pipe in all of our AI stuff to this. We're working to all together to get the Wyoming containers in there. So that'll be like the first step, is to get ASR, TTS back integrated with their existing voice subsystem and basically just get parity with all the features that you get today, but just more accelerated and on JETSON, and hopefully adding lower latencies to the system for more conversational based AI. And then from there, we can start doing more like video processing, advanced agents like we'll see in the multimodal VLMs and things like that. But first, we want to like just get like all the core stuff running. And it is a very huge project. It's overwhelming to myself even. So thank you to everybody on that Tiger team who's swarmed that and has getting us more quickly up to speed. And also, like this is a long-term project. This is going to take several months, I feel, to like really flesh this out and go over things. So first, we'll do all the Wyoming stuff. Then we can like add Revo or other more optimized ASR TTS implementations. We are continuing to look on. So we're really good with the TTS now. Here's some benchmark results from this, from running Piper on JETSON that we got compiled with GPU. This runs through Onyx runtime. We tried to get it running with TensorRT, but there was like some issues with building the engines for these. The good thing about this is it only uses like 384 megabytes of RAM for the high models, and they sound pretty good. And so that'll be really good for our goal to get like everything running on the JETSON Orin Nano 8 GB, including like small multimodal model, ASR, TTS, be able to like do the all up thing on there for not only education, but anybody who wants to get started at that entry level board with Orin Nano. So on the same time, and on the same end of things, we're now starting to look at Whisper, Whisper Edge, Distill Whisper, all of those like lower end ASRs to try to do the same thing there. Because currently the streaming Whisper we tried, it still takes up a lot of memory. It's laggy. We still have Riva ASR, of course, which is really low overhead and very fast, but still takes up like, I think it's like a gig or two of memory, because it uses like high-end audio transformers and stuff to make that work. So we want to really try to minimize memory however possible without totally sacrificing ASR and TTS quality. In my mind, we want to have like 10% or less of the system utilization going to ASR and TTS, because that's what I've seen before in those demos where I'm like chatting with Llama 70B, and that's what it took, because the LLM is going to like consume basically everything. So we need to have those running in as small a footprint as possible for to give all the large language models the rest of the system, basically. So yeah, the next plans with this, I saw Mazego's started to look at Wyoming Whisper container, and I need to do the Whisper container for Piper, and I need to integrate Piper into that Nano LLM stuff too, so I can like just do all the chatting with that. And I think then we should be in a good place for like phase one of this project, which is to get Home Assistant and their existing voice assistant workflow all running locally on the JETSON. And for a while, like we'll be like the prototype group of this before we go back and approach them to introduce this to their community on like a broader scale. And I know Seed Studio has plans they would like to engage in, because they make the Home Assistant green box for them now, which is like a little system that they advertise on their website that you can just buy, and it comes preloaded with Home Assistant. And it would be great if we could do that similar thing with JETSON one day too, and just comes out with all of the AI on it. Let's see, there's a comment here from Steve. Okay, ran Orange Pie with Whisper Tiny and Zephyr 3B. Oh, that's right. Yeah, we were chatting on LinkedIn about that this week. Yeah, we totally should get that a similar-ish setup on there. And I think the Orange Pi also has 8 gigs of RAM. So we're looking at like a similar model footprint for all of this. It just is, hopefully will run faster there. But yeah, if anybody wants to jump in and help with this, they're more than welcome to. Mazeiko's done a lot of the heavy lifting so far, which I really appreciate, because if you go in and look at some of these Docker files here, they are not simple with like how all the building works, and there have been lots of patches to this to get it all going. It doesn't take long to compile, and hopefully there aren't long-term issues with maintainability of this for us. And there's also open questions of integrating other add-ins like Zigbee and Z-Wave, and I have a couple of those here I have to find some time to test. But for now, I've not uncovered, like through the video testing and other plugins and things like that, I've not uncovered other incompatibilities with JETSON. It all just like seems to work as it should, I would hope, because this core container here is not using GPU at all. It's all these other Wyoming-based containers that we needed to rebuild on CUDA. Okay, does anybody have any questions or concerns or things you want to discuss about this project before we move on to next steps? Let's see. Sorry, go ahead.
Oh, yeah, I have a quick question, is because I just joined, I guess, the group today, so I'm not up to date on the project, but can you just quickly give an overview? What is the overall like objective? Is it to put some package down the line, or?
Absolutely. Yeah. The objective is to take all of this AI agent work that we're all working towards on JETSON and be able to integrate that back into Home Assistant. And they've already done a lot of great stuff with voice, much like an Alexa or Siri style assistant that's using like intense slot processing, like a car infotainment system or that style of Home Assistant, where you're basically talking to it. You're like, hey, turn on the lights here, or what's the forecast, or you have very specific command set that they're using, and they already have that through like these speech and NLP plugins that have it working pretty decent. Well, we want to get that all back running on JETSON at an accelerated rate, lower latencies in the system, and then from there start integrating in our higher level agents, which we are also currently building, but already have good stuff with like multimodal and like back and forth verbal chat and communication, and we're adding in like function calling and tools and things like that. So as opposed to just like a Alexa style assistant that you talk to or just give commands, something that's more conversational. And eventually we want to get this to be like self-learning and integrate RAG into it, so it can like remember your personal details, learn things about who you are. And you started to see that on some of the multimodal videos where I publish, where it uses zero shot to remember your face and who you are and adds that automatically into the RAG system. Once we add in function calling into the mix here, it should be able to automatically add its own data into RAG and complete this whole self-learning workflow. For example, if you tell it, hey, my name's Dusty, I have an important meeting later this afternoon, it should know to add that into the RAG database so that it can remember those personal details about you later. Not that we're going for like a full-on like calendar assistant here, but just something that like can kind of like generally learn who you are and prove like this whole self-learning workflow with RAG. It might be that we need, I've been seeing a lot of traffic about this like commander model command dash R. People are starting to do fine tunes that are specific for like RAG and function calling and things like that. So we might have to look into some other models. And this goes, we had a big discussion last time about this controller LLM that will sit on top of the system and basically set up the pipeline of, VLMs, other image, video, vision, audio processing blocks in there to achieve what you want that calls all these functions and tools. And all of this will is like a long-term, multi-month project. I hope like into the summertime we have something that's actually some semblance of intelligence. And I think doing that whole self-learning loop where it basically starts from nothing, but then just gathers data on its own without you strictly needing to tell it things, then it will learn over time who you are. And people can use this for all types of applications. Whereas our thing here is like, well, most of us are all remote and work from home, and this is like the environment that we have to work on. But there's people in this group from all walks, people in robotics, smart IoT, these home assistant types things. So here we are coming together to be able to like leverage each other's work. There's all the model updates and API updates, and they're not slowing down at all. They're only like speeding up, and we can help each other by collaborating on areas that our work overlaps, and then go and apply all of that to our individual applications. Does that answer your question?
Yeah, perfectly. So I would imagine also that very little or no reliance on cloud then in any of these models.
Yeah, well, yeah, that's the whole point. Is like we were running this like when I was showing those video feeds, right? I would never have cameras on the inside of my house if it was going to the cloud. And yes, Home Assistant does have cloud integration either through Nabu Casa, so you can run a Home Assistant that you don't have the box locally, and you can pull sensor data from the cloud. For example, I like quickly set up the AccuWeather plugin just to like test that their integrations were working and stuff. But in general, we want to be able to show that like you can completely disconnect this system from the internet and be able to do voice and video and all of that without having any reliance on the cloud, because like people are sensitive to their personal data in their home with their family, and like I don't want that stuff going to the cloud either.
Yeah, I mean, I would think that would be a big selling point for these type of application.
Yeah.
Versus, yeah.
And that's just to mention like the privacy side of things. You could absolutely have these home assistants or like your phones, everything's running in the cloud. When we start to talk about like robots that you're into, then it becomes much, much more important that you have all this, not only from latency and safety, but I mean, how many times you go around like your cell phone signal is not great. Either you're out in a remote location out in the woods somewhere, or you're in city around big buildings. You just can't rely on that when autonomous navigation and other safety critical systems are involved with things. Which like the cyber physical integration aspect that we're all interested in this group, basically bringing generative AI, LLMs, advanced AI to real world devices. We have like a lot of things we need to be cognizant of with that, because like these things are causing actual impacts in the real world, whether it's like an actuator or some other IoT device that interfaces with real world systems. So we have some more real world concerns than other cloud systems might be, where it's just like a web UI, Let's catch up with the chat questions here. There's a thing like, do not pip install Ollama. Yeah, yes, which is the reason that we do this whole container stack and everything. You're like, why do I have to like do it this way? I don't even like containers. And like, I totally get that, because I used to not be a fan either, until I like blew my JETSON up so much and have to like reflash everything. Because yes, if you just pip install stuff, a lot of times it will go out and just pull the CPU only package for it, because what's in the pip repo was not compiled with CUDA, because it just sees that you're on AArch64. Is somebody else trying to talk? But basically, we have set up our own pip server now that mirrors PyPy and should avoid those type of issues. Because what's worse is not only will it install the CPU version, it will uninstall previous versions that you installed. For example, if you manually installed the version of PyTorch that has GPU enabled, it will then go uninstall that, reinstall the CPU one. And I know Brian was dealing with this week. It's just like,
yes,
yeah.
It was horrible.
Stories, right?
Yeah, so because I'm working on several other components, and so I pip install stuff, and the worst one was OpenCV, was because it decided to uninstall the OpenCV, and then it installs all these other dependencies, and then when you try to manually reinstall like OpenCV and PyTorch, there's all these secondary dependencies throughout these various packages that are now broken, and so then it takes you down the. Go ahead.
You're mentioning OpenCV. What I learned is, if you try to install an OpenCV that is not the one that comes already installed with the package 4.6 or whatever, forget it. The IMX 219 camera will not work. You just busted the whole system. You will have to reinstall from scratch.
It's because
so I pulled the OpenCV from it's the wheel that's available from, I think, Zoo. NVIDIA Zoo. There's
which I built that.
Yeah. So I just pull the wheel down and I have it, and so I can, when I reflash, I have it on an NVMe. So I followed Dusty's suggestion. So when I reflash, I flash on the MMVE or whatever, and then I have an NVMe 1 terabyte. And so every time I reflash, all I have to do is remount my terabyte disk, and I'm good to go.
That's what I do.
And the reflashing, and I spent 2 days or a day reflashing my JETSON Orin AGX just because of it's a mess.
Yeah, reflashing takes at least like half a day for me. And like Jetpack 6 GA will be coming out soon, and it was supposed to be out today actually, but it got delayed due to like other issues found in SQA, and it'll be out in like 2 weeks or so. And again, like these things, it can keep getting perpetually delayed if we find blockers. Again, because JETSON goes into like safety critical systems that need like, we do not put out releases until it passes everything. But yeah, the issue, Alvaro, you were speaking of in particular with IMX 219 not working all of a sudden, is because the version that pip has for OpenCV was not compiled with the GStreamer flags in it. And there's like all these other flags in there that you got to make sure OpenCV was compiled with. And that in a nutshell is why I have all this automation in JETSON containers and all the tests, and like it boggles the mind, but that is why things like are the way they are there. Not that you even have to like use the containers, because of what I've done now is the containers are basically just glorified pip wheel builders, right? That make sure all the right wheels get installed and tested correctly. And now I have that pip wheel server out there that you can just install my wheels that the build system outputs if you don't want to. But like Brian was doing that and still like blew his system up with like Conda and whatever. So even if I use containers mostly just for development, so you can just mount in your project files or whatever, and I still recommend just to like use that, because like worst case you just like wipe the container and you're not spending extra time refreshing.
You know what I do? You know what I do to keep the system safe, which sounds silly? I just get the SD card, I put it on an SD card reader, and I make a backup, and I save it on my Windows. So if I blow something up, I will just reflash the whole thing, and so I don't lose that much work. But your solution, of course, makes much more sense.
Yes.
Yeah, I would definitely recommend installing a 1 terabyte NVMe on it, because it survives flashing.
It's actually amazing we've gotten this far with everything, like this whole AI stack with all the LLM, VIT packages, everything. It's actually pretty amazing that it all works. And we're able to like rebuild all of this for ARM plus CUDA and like keep it all going. And that's like what enables us to do everything essentially. And I still spend like an inordinate amount of time on it.
And real quick, I threw my email, brian@nosy.ai, if people have any reflashing concerns, because I've sort of earned my badge of horror.
Yeah. Well, and that's the thing with it. Sometimes you just kind of like cut your teeth on things, and like the same thing with the LLM.
Feel free. Yeah. Feel free to email me, and I'd be happy to answer any, give suggestions on the best way to reflash if you're having issues.
So with the discussion about like all the container stuff, let's segue into a quick discussion about updates on the container system, which I updated like the syntax a little bit for like how you build and run these. And you can now do this from like any directory using these commands that look like this now, which hopefully that'll be nicer for everybody, and as opposed to just like shell scripts that are in the repo. And those are all still in there and everything, but you can use like this new way. And again, like these commands will just spit out the Docker commands that it generates to run. So you don't need to use these helper tools at all. And there was questions about, well, how do I take these and then build on top of them? In the example of like our inferencing APIs and stuff, there are directions here for changing. You can either use your container that you've built as the base image and build our containers on top of yours, or you can basically use the output of JETSON containers as your base image and build your container on top of that. Or, as I mentioned with this pip server, you can not use containers at all and still benefit from like all the packages that we have going. That's at this URL here. So basically the output of all of the build scripts and everything in JETSON containers, they all get cached on this pip server that I set up here. And this was essential to scaling, to being building for like different versions of CUDA and being much more portable, because we're already starting to see that. One thing I've been working on the last 2 weeks is now that I have build for any CUDA available, I'm able to get CUDA 12.4, TensorRT 10, and we're starting to work on getting TensorRT LLM support. I have it building. It's not fully working yet, but we're targeting TensorRT LLM 0.10 release to be working. So I need those engineers to help a little bit for that. And then TRT LLM will be integrated into this model API here, and you'll be able to use it just the same way as this uses MLC today. And this is for all like the high end optimized. Basically, if you're doing like multimodal stuff and want like the fullest performance, check out this Nano LLM, which used to be called local LLM, and like we've transitioned that now, and the containers are up for this. And it's got a very clean Hugging Face like API, just with like the full 50 tokens per second of performance, whereas you'll get around like 25 or 30 through Ollama and llama.c++, which is fine for text chat. But for multimodal stuff, you probably want higher end. And in the past 2 weeks, I did also add a code example just for doing the live lava esque type processing here. So like if you don't want all of the other plugins or web UI or any of that, you can, this is the flow of just taking in a video stream or image stream and applying the vision language model prompts to it as fast as possible. So basically here, it just loads the LLM, the VLM. It's literally just an LLM plus clip or SIGLIP vision encoder that it does for you. It makes this like chat history object that manages the KV cache and makes it so you're not recomputing all of those big images every time, because every image is like 576 tokens. So that is why I do a lot of this the way it is because of caching all of that, because otherwise you're going to lag out on every the bottleneck of this whole live vision language model system is the pre-filling of that 576 image tokens. And we'll get to like streaming all of that, including multiple frames, because Vila, the model we've been using, can do multiple image frames and be able to answer like questions about what changed. Or my ideal vision for this is like there's just a stream of frames coming in sampled at like 1 hertz or whatever, and you just ask the system repeatedly what changed versus the last image, and then it just spits that out, and then you can run your event detector or whatever based on that. And that should give you a very broad, generalized type of system where it'll pick up like anything that's different, and you don't have to ask it a particular question. You can see here, this is just like a loop where it pulls in any image. This can be like a CUDA image or a PyTorch tensor or a pillow image or like whatever. And then you append it into the chat history, run the generation on it with the question that you asked. And then that's basically it. You just like iterate over it. Everything else that I have in there, and the more complicated agent for like RAG and all that other stuff is just a more advanced version of this. Yeah, but we're going to continue working on that, add in like the function calling and all of that stuff. But we have been very busy on like the HomeAssistant side, and I want to make sure to keep all of those containers ungated, and when people like Mizeko and Ridge Ron and everybody's been contributing, pushes a PR, try to get that merged and built and pushed to Docker Hub as quickly as possible. Okay, so with that, it's good we went through all the updates and still have time to discuss the like robotics kits and things like that, because that is a very important topic. And a lot of what started like the JETSON community and really grew big was with like the $99 Nano and this cool JetBot autonomous robots kit that anybody could get and learn to train their own DNA. This was also like a self-learning system, and those type of systems that you can run onboard JETSON, onboard edge devices, and either like train small PyTorch models on board, or be able to collect data into the RAG system, are very effective for users, not only for like learning AI, but for like adapting it in situ in the field. And this was just done through like Jupyter notebooks, and there was it trained a ResNet 18 model on board, and this was on board the original JETSON Nano 4 GB, and it worked on like the 2 GB version. So we've done like lots of training and stuff on it. And then since then, CMU has made some really great courses that have integrated ROS and added in advanced features like SLAM, reinforcement learning, simulation. They have April tags working. This was with the CMU Robotics Academy, which is like a little tangential to Zayed, who's in the ECE department. He's been working on the Orin Nano version of this. But there are lots of courses like this that have been built on top that have all this advanced functionality that are open to curriculum for teachers or makers, hobbyists, and anybody from like a middle school student to like a retiree who's like just getting into this for fun is accessible to everybody to make their own autonomous robotics kits. And they also were like distributed through people like Seed Studio, Spark Fun, Wave Share. You can get these off of Amazon, just click and buy. Even the original version, we have all like the 3D printed CAD models and stuff for. Unfortunately, the JETSON Orin, or the original JETSON Nano, is now end of life, and you like can't really get those anymore. And we still have a need to officially update the JetBot kit for the Orin Nano. And at first, it was like, well, the JETSON Orin Nano is really kind of overpowered for what this JetBot is doing. But now that we have a lot of this great generative AI stuff running, the LLMs, VITs, Isaac Ross is available on Orin Nano, it makes a much more compelling use case to be able to show more advanced autonomy and agents being able to run on a small little cost-effective platform like that we can use for teaching. And in that vein, Zayed has worked very hard for basically like the past year, I think, right, Zayed? Since about last summer is when we started emailing back and forth. I remember because it was right when I was really getting into the LLM stuff, and I was like, oh, normally I would be there right beside working with you on this hand in hand. But it seems to have gone pretty well for you.
Well, I mean, it depends how you count time. We definitely started in the summer, yeah, and I think you were a great help, but I think I had to turn my attention away for the fall for other courses and then come back this semester to create this new course that you know about now. But it's basically the idea was I wanted a course that student come in without any background in either machine learning or robotics, ROS 2 basically, and have them come out at the other end with basically both and integrated with Isaac ROS. So it's a big objective, but I think we're getting there. So this semester we offered this course as a pilot course. And I told the student, you are on the kind of the guinea pig, so to speak. They didn't mind. You would think
and this is an undergrad course, right?
Well, so it's cross-listed. So there's a mix of undergrads. They tend to be junior seniors. They're definitely a big portion masters, and there were at least a couple of PhD students, but I don't think they're able to accommodate the timing. But it's a unique course because it actually kind of mixes the undergraduate and there are two sections basically, one undergraduate and one graduate. So
nice.
So
okay. And you had sent them. Let me share a picture of your kit real quick here, because there were a couple other upgrades that you made to it as well. So you can see here, you can tell this is the Orin Nano because it's got like the heatsink with the fan on it, and you're using a real sense. Is this the D35i on there?
The 435i, yes.
435i. Okay. And this is this is nice. And I don't know what type of battery you needed, but it would be
so the same as the JetBot, except we had to use two of them because the 10-volt requirement for the Orin Nano.
Okay.
And you would think it's a no-brainer, but it's finding that solution actually was a bit,
Yeah, because like these are just like little USB battery packs like you would get from Amazon or whatnot. And it's just kind of funny that you can just like use those and they fit in there. But yeah, at some point we'll have to get the bill of materials that you use to update this. Because on the hardware side, we can just point people to say, oh, you can take because there's like thousands of these JetBots out there that I'm sure people would love to be able to upgrade with the latest and get all the latest AI tech going on there. Isaac ROS simulation you can now leverage, like running Isaac Sim in the cloud or on your laptop and being able to do sim to real and all of that great workflow. But on the hardware side, yes, there are some minor modifications that would need mostly the battery pack, because Orin Nano takes a bit more power than the original Nano, which was when the original Nano was on JetBot, we were running that in 5-watt mode. And now the Orin Nano comes in 7.5 or 15-watt mode, I believe. And you can like change that and set it all like up yourself, what exact power draw that you want it to have. But suffice to say, it needs a little upgrade on like the battery side.
Actually, I thought about something. My problem is that I cannot fit my JETSON Nano on a battery pack because it pulls 4 amps, and I do not know of any battery pack that can pump.
It's going to last for like that long of a time.
So what I'm thinking, and maybe the question is for people with a little bit more background on electronics than me, maybe get 2 battery packs of 2 amps each, mix them together, and plug it into the barrel thing. Will that work? I'm talking
so basically what we did for this course is connect them in series. So each battery pack each battery pack on its own has 2 outputs. Each one can provide 3 amps. So when you put them in series, then you still get the 3 amp, but you get 10 volts. So that gives you the 30 watts. That is enough for, I mean, and you have to count also not just the Orin Nano, but like the camera plus the Wi-Fi module. Actually, we use also the SSD module, which adds quite a bit, actually, a few watts. So if you add them all up, you have to be under that 30-ish watts.
Yeah. Okay, 30.
But
yeah.
but my problem is not the voltage. My problem is the power. So maybe if I put them in parallel, will I get 4 amps? I'm not a big guy.
Well,
Yeah,
yeah.
you have to look. You have to look at the. You have to look. So the Orin Nano requires, I think, at least, if I remember top of my head, 9 volt to like 20 volt, maybe. Dusty, do you know?
It's in that range. Yeah.
Right.
In general, that's what you're going to see, because like 12 volts nominal. But yeah, and like the battery discussion aside, we're always going to have, like, if you're in development and want to be running this for hours at a time, there's no battery pack that's going to fit on a small little thing like that. And I've seen, like, we did summer camps with the Boys and Girls Club here in Pittsburgh, and they had like 20 of these running, and yet they just like connected a wire to the thing while it was running like all day, because they did that. And other people I've seen at like trade shows with events, they always have like hot swappable batteries for things like this. And while a lot of what we see in robotics is not just like an increase in AI compute in the models, but like battery tech has come a long way. Mechanical engineering has come a long way. So like the battery density continues to increase, which is helpful for us. But yes, there are still limits, especially when we're like trying to make this thing as small and lightweight and cost effective as possible, especially considering like we're all mostly like software and a little bit of like electrical engineering guys. But I know, like, from working with guys at CMU, like the actual mechanical engineers, they're like a world apart in what they can like actually achieve with their designs. So for now, like, yes, you can go onto Amazon and find the densest, biggest battery brick USB pack that you want to put on there. And then most of the hardware issues are resolved after that. I think it looks like you put a little bit of a custom mount on your Zaya to mount the D35i on there, and it was also like looking at the ground too.
Yeah, so that is also 3D printed, modified actually the JetBot. So thanks for having access to the design file, the Fusion 360 design files for the JetBot. So modified it to actually fit the bigger battery packs. And so those were some of the changes. For me, it was essential that I'm able to change the chassis because I wanted to accommodate, I want the camera mount to mount that way, or, so things like that. So
along those lines, because to zoom out on this discussion a little bit, because eventually you want to like publish your course like edX style or like open source, and we can get all your updated design files from that. But when it comes to like mass producing these or offering off the shelf through like Seed or Boom or Waveshare or whatever, most of the time they have different designs because they like are more focused on like the manufacturability of these. They're not generally 3D printed the same way. They do change things. And what's actually more important than an overall specific design, like what battery you're using, is that the software with JetBot or JetBot 2.0 or whatever we all go out with this will work on anybody's variant of JetBot, which is essentially just a differential drive with at least a monocular camera on it. And most people these days are putting some stereo or time of flight and like wheel encoders on it. But if we could all like converge all of our work between the original JetBot, the stuff you guys at CMU are doing, other people in the community, and like get that all back into Isaac Ross launch files and make like all the tutorials around that, so people can just take that and run it on any JetBot-esque platform that has an Orin Nano on board. Then I feel like the issues that we faced in the past with like portability to other variants, because there's lots of these on Amazon that you can find, or different distributor websites, and we want to make sure that they just like work out of the box essentially.
Right.
But
Well,
yeah.
I mean, the objective that I still, we're working with Joe Bongo from the DLI about having the material as a teaching kit. So it still needs to be worked out, but that's the objective, is having the JetBot plus all the teaching material as a teaching kit, or
Yes.
that we would put out there so that people can adopt it for education purposes.
Yeah. And we have
course.
that for the original one. It's very difficult to keep all of that stuff updated, because it feels like we just finished it, and then all of this new stuff comes out, and to take from like basically what we have on GitHub to putting it in the hands of teachers and educators and professors, community groups, and the whole reason for motivating us is like, yes, everybody on this call is like actually pretty like far advanced technical, and we want to make AI very accessible. That's one of the mission statements of this group, is to make it available for all, AI in education, so that anybody can get there and be able to leverage all of these advances in AI to benefit humanity, the planet, themselves, and not just make it some far off concept that you need to wait for like other companies to provide for you, and being able to run that all yourself in your own home locally without the cloud or internet, like that all jives together, right? So it is very important that, since like JETSON Nano is NVIDIA's like entry-level AI product that anybody can get into, that we make these kits available and needing updated. It's a challenge to keep up with the pace of things. But I think migrating to like this ROS-based software, like you have done and everybody else is doing, will insulate us from changes in the future, whether it's the specific hardware or new features or new processor, whatever.
I mean, to be honest with you, I hope so. I can tell you, we started in the summer with Jetpack 5.1.1. Now the course is, okay, well, Jetpack 5.1.3 or Jetpack 6.
Now 6.0 GA.
It makes running a course very challenging, I can tell you.
I understand, yeah. And like we're constantly, one funny thing about Jetpack, right, is when it started off with TK1 and JETSON TX1, it was way more pared down. It was like the L4T BSP, you did flash.sh, you installed CUDA and stuff. And then it got more advanced as the stack grew. We wanted to streamline it for users, and then it like installed everything for you automatically. And it was different from other like desktop PCs where you like went to the CUDA website and downloaded CUDA and installed that. Well, now we're back to that, where the CUDA, cuDNN, and TensorRT teams are now publishing their installers for JETSON and AR64 right on their website, which is now how we do that build for any CUDA in your container stack. So now what I'm getting at is, once you're finally on Jetpack 6.0 and like caught up with all of the Linux kernel changes we've upstreamed and have moved to this much more like open-esque platform type of deal, then you hopefully shouldn't have this issue in the future, because like Docker will just act like Docker should behave, which is like not mounting stuff in from the host device. And you should be able to run my latest CUDA 12.4 container on any Jetpack 6 variant and whatnot, and be able to get caught up with the latest without having to worry about porting all those like BSP things and stuff. But I get what you're saying. Let me catch up with some questions here. Oh yeah, John's here. John Welsh, he was like one of the original creators of the JetBot and pointed towards these 18650 BMS cells. And that is what our guys look at internally is yes, these like USB battery packs are easy to work with, but you can also just get like lithium little cells. They look like a AA battery, but are actually lipos in them, and you like chain them together into whatever configuration you want, and with the added advantage of they're smaller and denser, and you can wire them in parallel or series to achieve like whatever voltage that you need there. And again, there are other platforms like the iRobot Create 3 at this price point. I think that thing is $399. I have one of them here that I've been meaning to mess with, but it's basically like a Roomba that runs ROS on it, and then you can add there. Okay, oh, Steve's got the cells. Yes. But the iRobot Create 3 is another off-the-shelf kit that we're targeting, and is nice because like it already has ROS integration, and the JETSON is essentially a coprocessor that goes on it, and like you don't have to worry about all like the battery stuff or like things with that. It's like a pro produced product because iRobot makes it, and they're very into ROS also. Let me catch up on some more questions here. Was Jetpack 6 released today? They like just joined. It was not, unfortunately. It should be out in 2 weeks, tentatively pending final SQA results for that. Catch up on some other questions here. Somebody somebody commenting about now you can get Ubuntu outside of Jetpack. Yes, and you're going to start seeing that more and more. Like Red Hat, Fedora, whatever, they will just make ISO images for ARM and JETSON that you can install without Jetpack, because now we have all this upstream Linux kernel goodness, and you don't necessarily need all of that anymore. Although, like for all of our like official tutorials and stuff and things like that, I will just use like the normal vanilla Jetpack image. I'm not going to go off and be doing like Arch Linux or Yocto, but those things are like very good for embedded. It's just like the overall general community support, I will stay on like the mainstream things. And a lot of the ML stuff like assumes you're on Ubuntu basically, because all of like the packages they install. But enterprise grade stuff that NVIDIA does, whether it's through like Metropolis or TensorRT-LLM or these NIM microservices, that they compile for like CentOS and RHEL and other things, because like that's what people are using in like production grade deployment for things. Here is a question about estimating the latency of models on hardware. And if I take the flops of the system, can I just estimate it? It's just easier just to run it, honestly, at the end of the day, because there are so many things in there. We have some like simulation guys internally that can like calculate what the chip is due from the design files they have, and like with the algorithm that they take and say, oh, this should be the maximum performance. That's how I know on the LLMs we're doing really good, because they predict the maximum performance you can get from Llama 7B is 50 tokens on AGX Xavier, based on like memory bandwidth and things like that. And lo and behold, with MLC, we get 47 tokens a second, which is like really, really good, and is super optimized, because it's like this virtuous cycle where NVIDIA published, optimizations like Cutlass, faster transformer, and those get integration into Flash attention libraries. All these libraries take like hours to build and are super complicated, because if you look at modern C++ code these days, it's just like a tangled mess of templating, and basically the entire thing is just a gigantic CUDA kernels that are templated out based on like when it goes and builds your model, it says, oh, for this Llama layer number 2, it has this layer configuration, and I need this type of matrix multiplications and such to do it. And it'll go off and build the kernel just for those dimensions and be super optimized for that. And all of that is done at like build time of the model through Cutlass and these other libraries that MLC and TensorRT-LLM integrate, and that's how it gets to be so fast. And that's also why the binaries are so huge, because it's just loading like gigs of CUDA kernels and stuff, and why those containers are like 20 plus gigabytes in size.
Actually, Dustin, you're talking about C++. The other day
I'm talking about like what modern C++ code looks like, which is like a departure from like what I'm used to writing even.
No, it's just I code with Python, but I'm getting to I'm having to move out because it's way too slow. And then the other day, this guy tells me, why don't you learn Rust? Because it's compatible with C++ and it's easier. I was like, well, so your thoughts on it?
Yeah, I
Good.
think more and more everybody seems to be like moving towards Rust too, if you're in like the robotics world. And that also plugs it all back into the Home Assistant thing, because I want to have like these little JetBots and stuff roaming around your house. I have like a little telepresence robot here that we're going to put this all on, and those will hook in to the Home Assistant system too, through their REST APIs that they have available, and be able to query it, and like all of this like work cohesively together. And anyways, that's like the grand vision. It might take us like a year or whatever until like next spring. We'll see how quickly we get. But I do like really appreciate everybody's involvement. And as always, if anybody needs any help on their end on anything and has requirements or features that they're missing out on, they really need model XYZ supported, give us a shout on the forums, and we're happy to help. If there are any more questions or anything, I'm happy to stick around for as long as people will chat. But I'm happy today's meeting ran much more on time than the kickoff meeting last time. As far as the JetBot stuff goes, we will continue. That's like the Home Assistant, that it will take time to not only work with system integrators and the distributors for it to upgrade, but we'll work with the likes of Zayed and others to basically, and there's also Raffaello's Nanosaur and other projects in the community. Basically, we need to gather all of those like ROS-based projects that everybody's done and merge them all into like one cohesive software project, so that we can stay insulated from individual platform changes, and also so like anybody can build their own JetBot and be able to do this like self-learning style thing. We will stay true to the mantra of JetBot, where it's like robotics and autonomy 101. How do you go from basically nothing to training your own robot to follow paths or avoid obstacles, and ideally eventually end up with one that can like remember the different rooms in your house, or you'd be able to tell it, hey, go into the kitchen, or and it'll remember where things are. I've seen some cool community projects recently that work on that exact thing with the likes of Slam, and I think we will all learn a lot from integrating all of the agent LLM stuff that we have with like the more traditional-esque robots and all the VITs and stuff. And also the Isaac Ross team has also been increasingly interested in adding generative AI and things like that to their roadmap too. So I think you'll see the nexus of all of this coming together. And in the meantime, the humanoid makers are forging ahead too. I saw just yesterday Boston Dynamics released a teaser video of like their Atlas 2.0 and stuff. So everything going on is super exciting. And like, yes, while we all personally don't have access to like all that high-end hardware, we basically are building the brain of it too, that should be able to be dropped into any of these platforms, that is open and accessible to everybody in the world. I see the Carnegie Mellon Robotics Academy mentioned. Okay, this is a good point about the Jupyter Lab interface. Okay, let's talk about this, because this is a big direction setter of the project. And I know John Welsh is also a fan of the Jupyter Lab interface to it, which is unfortunately a little bit at odds with ROS. So if Jesse, if that's you speaking from the CMU Robotics Academy, if you could speak to like how did you bridge Jupyter Lab experience with the ROS experience? Hopefully in the future we can get best of both worlds out of that, because I'm not sure how to like reconcile it all.
Yeah, so we do have two modalities inside of our course, and we do a lot of the Jupyter Lab stuff at the beginning, and then follow with the ROS stuff.
Oh, you do both. You do both. Okay.
We do have both, and the truth is that the ROS stuff is pretty fraught for a lot of our audience. So
understand. Yeah.
Insofar as you want to
even I don't like it all the time.
Well, insofar as you want to get into like community colleges or high schools,
yeah,
they're running networks that have security protocols, and it's the
Oh, you're even
West.
just talking about the networking. I'm just talking about even just this notion of all the ROS packages and nodes and like launch files and all.
Yeah,
And
so
there are nicer web UIs for ROS now, like Foxglove. And have you seen with many of our demos, it's no big deal anymore to like roll your own web UI with HTML5 and JavaScript. And we can provide that Jupyter-like workflow in a web UI that runs ROS underneath. In your experience, were people actually doing the coding aspect of Jupyter Lab for JetBot, or was it mostly just like a nicer interface to run things through?
well, it was a couple of things. So the networking thing cannot be discounted. Like even here at NREC,
That's
we can't
always
run-
an issue. Yeah,
yeah,
and because like we all develop it, like the most we might have is like 3 or 4 of these, and that's when we're really doing like all up testing. Most of us, all of us on this call, we're only going to ever have one. But then yes, when teachers, professors like yourself get in these situations where they have like 20 of these in a room, it really exposes like the networking and the Wi-Fi issues really quickly.
Yep. And so for us, one of our audiences is like robotics technicians. And so in that case, we lean into ROS to teach those things and to show that it matters. But for the high school audience that you want them to be, up and running, training models, collecting data, Jupyter is really powerful for, being able to reset the interface, be able to give them, that clean experience. You might have robots that are shared
I guess
from one student to another.
Yeah, my question was, were they actually using Jupyter to do the coding it? Because one thing we noticed with the JetBot notebooks is like, yes, there was the road filing one and the collision avoidance one, but then when people wanted to like combine it all together, it was really like a spaghetti mess where you're like copying around notebook, and like you don't want to have to do that. There needs to be like a JetBot library that is like much easier to use. And in my experience, like people were not learning to code through these Jupyter, because it's a weird hodgepodge of like, yes, Jupyter is very good for data science. You got your like CSV data in there and want to process it and be able to run the same cell over and over without like doing Python scripts every time. But for like real-time embedded systems, it's not, everybody's just like point and clicking on the cells. They're not really doing like the coding through it and like not learning like PyTorch training models and stuff. But what if we could have a similar like web interface that gave you like the data collection, training workflow, set the robot navigation mode, set up the pipeline, and did a WebRTC real-time camera feed view, much like you see in our current demos. That's just like HTML, JavaScript, WebSockets. And it would do you think that would be good? And in the underneath, it is actually running ROS. It's just like a nicer web UI built on top of ROS.
Yeah, I think your observations are spot on. There's early on in the sequence where it's, sequential robot programming, no real autonomy, and you see programming there where they're just doing sequential robot movements.
Yeah.
But once you get to the point of obstacle detection, it is definitely just following along with the science experiment more than learning to
right
code.
Yeah, well, and it's not as if we don't want to like teach people to code all this, because like eventually like you got to jump in and like learn how to do it. That's why we've made like the LLM API so easy to use. Everyone's like, wow, it must be super advanced ones. Actually, it's super easy because it's just the general nature of it. But yeah, I think if we can find a happy medium in between there, where like the system is modular enough so that people can change out the underlying platform, add new functionality, combine modalities and functionality, but also be able to easily learn from it and edit it. Because admittedly, if you look at some of these ROS2 launch files, they're not good examples for like chaining like together in your mind how the robot pipeline works and things like that. So there certainly is, like have you done in your course, a ROS education aspect of this. You got to teach people the ROS stuff first. But I think, given the compute available on Orin Nano, the fact that like everything's moving towards ROS for simulation and like these accelerated nodes and everything, and its prevalence in the industry that we should probably look at formally adopting that for the next gen JetBot. And that isn't to say if people want to do lighter weight frameworks, then we like support all of that as well.
And thus, if I may add, if the objective also to do Isaac ROS, currently the only way to do it is through actually C++. So you can, yes, I mean, I can see.
Interesting.
Yeah. So I can see the, building the, from a.
Well, yeah, all of the Isaac ROS nodes themselves are implemented through C++. And for those already familiar, Isaac ROS is basically just like our ROS packages that are highly optimized and GPU accelerated and do like zero copy between nodes, so you're not like copying around data all the time and stuff like that. But my understanding is those, just like any nodes in the ROS system, ROS doesn't care if it's a C++ or Python one. You can have other nodes and launch files that call those C++ based ROS nodes just the same. But you're talking about like if you want to go in and edit our Isaac ROS stuff, or like take April tags and add stuff onto it, then you're working in C++.
Right. I mean, so if you actually want your node to be on the GPU running along with the other nodes, so you're not going back to GPU, CPU, it has to be.
If you want to use Nitros.
Nitros, yes.
Yeah. Okay. So Nitros is this zero copy transport. Essentially, it's like CUDA managed memory pointer sharing between ROS node processes, because ROS nodes, they run in like different processes and like they figure all that out. I will have to discuss that with Isaac ROS, because I know that has been mentioned, like streamlining Nitros, making it simpler and easy to adopt. And I totally get what you're saying there, because at the end of the day, the throughput's important, especially on these Orin Nano class of platforms. But also for like the time being, you could just like you can use CUDA acceleration in PyROS nodes, like just call CuPy or CUDA Python or other like GPU enabled Python packages, which is what most of us are using these days in like all of the other stuff. Is those Pythons is just a glorified API on C++ CUDA extension wrappers underneath. And like I used to do all exclusively C++, and now mostly do Python stuff just at like that higher of a level. And also with like ROS, I think having a lot of the launch files in Python is that seems to be the preferred way, and like is digestible and simple. Once you get into like they're all YAML or whatnot, it gets like really complicated for people to follow. But okay, that sounds like a plan. We will continue to meet and let this simmer. And Zayed and I are going to get together next week, because we're fortunately both in Pittsburgh, but have never met, even though we've been working on this for like a year. So yeah, it's time to like actually put a stake in the ground there, and hopefully by like summertime. Ideally by like the fall, people are going back to school, ordering new kits. We want to have JetBot 2 that you can go on Amazon, click and buy, and comes with Orin Nano and runs ROS and does some speech, Gen AI stuff. That is the other aspect of this, that like, yes, we, on one hand, we are trying to get this all up multimodal agent with speech services running on Orin Nano, and then on the JetBot, all this Isaac ROS stuff. It will not all be able to run simultaneously in 8 gigs of RAM. But also somebody that's on the real high end could get an Orin NX 16 gigabyte module, put it on the same JetBot with more battery power, and be able to run all of that simultaneously. Although at that point, like the platform is probably more suited for like a Create 3 or something of that nature. But again, if we're all just running ROS, it doesn't matter really what you're on. It's just like our educational teaching materials for JetBot are portable to any ROS-based system. Yeah.
Do you mind spelling out this Nitros stuff in the chat so that I can
look
for it?
Let me link to it here. It is NITROS.
nitrous.
I would screen share it, but I'm happy today my screen share didn't crash Teams. That's great. And like we are on the ROS working committee and have this has been a long-term thing. And going like JETSON containers before it grew into this like huge, massive, crazy complex build stack, it used to just be like 5 Docker files and some build scripts for like PyTorch and TensorFlow, and ROS was one of them. So we've been building these ROS containers for people for years and building all that support in the community all the way back to ROS Kinetic, you know, and Melodic, and now most people are on Humble. And yeah, it's been great to see the uptake with that, even though everybody like has their pain points and gripes. Overall, I think it's been a positive direction for the community to head in. So we've been doing pretty good on time today. If anybody has any further topics or questions that they would like to discuss, I'm happy to stick around. But otherwise, we'll plan to get together in another 2 weeks and see what additional progress that we can make. At any point, people feel free to hop on forums, GitHub, and if you do make any contributions or PRs, you know, I always try to merge, test, and build those as soon as possible to ungate everybody. And hopefully in the next 2 weeks, we can get some more speech stuff actually running inside HomeAssistant. I hope to have TRT LLM running within the next month, you know, around like the Jetpack 6 GA timeframe. I really want to get the function tool calling into Nano LLM, and there's just like so much going on, which is like why we need everybody band together and we can like all get there together working on things. So yeah, I really appreciate everybody's support and coming to these meetings, and it's been really great. I will post this recording to YouTube later and on the website so that people can watch it. Looks like we're all caught up with the chat. So with that, we will end the meeting. We're only 15 minutes late. Great. Thank you, everybody. Have a great week. I don't think we're done for this week. There's a lot more still to come. So have a good one, and thanks so much.
Hello.
Thank you. A good one.